Today we are going to cover the diesel effect. Although extremely rare, it is a good lesson in best practices. Looking closely at this depiction of a diesel engine and remembering the combustion triangle, we can see how the diesel engine combines the fuel source in vapor form, combustion air, and the ignition energy created by pressurizing the chamber, creating enough heat to create a controlled explosive reaction. Comparing the diesel engine to a compressor, there are many similarities. Under normal conditions, however, the AC compressor is not designed to compress air, nor is it intended to withstand small internal explosions. Non-condensables cannot compress, creating an increase in temperature and pressure in the system. When refrigerant oils reach a maximum temperature, they can combust. If the non-condensables contain oxygen, the potential for an explosion is high. Both refrigerants and oils have an ignition temperature. POE oil is used in 410A systems and has an ignition temperature of 1,194 degrees Fahrenheit. If the pressure increases the temperature above that set point and oxygen exists in the system, diesel effect will likely occur. By following best practices, we can eliminate any chance of the diesel effect. It is important to note, diesel effect is caused by human error. It would be highly unlikely that air at 14.7 psi could enter a piece of equipment due to a leak in the system.